Hey guys, so today I'm going to demonstrate on how to calculate the time of sunrise and sunset. But before that, we must know why is it important. So calculating the time of sunrise and sunset is crucial in navigation because it helps us to determine a ship or plane's position on the Earth's surface. By knowing the time of sunrise and sunset at a particular location, navigators can calculate their latitude and longitude using a sextant and chronometer. This information is then used to plot a course and navigate accurately to the desired destination. Additionally, the time of sunrise and sunset can be used to estimate the length of daylight hours, which is essential for planning and scheduling activities during a voyage. Thus, accurate calculations of sunset and sunrise times are vital for the safe and efficient navigation. So, scenario 1. At the Royal Observatory, Greenwich latitude has a latitude of 51 degrees, 28.6 minutes north on the 10th of April 2023. So, this is our given. So, time April 10, 2023. The latitude is 51 degrees, 28.6 minutes north and has a zero longitude. So, after that, we must find the latitude in the almanac. So, our given is the time is April of 10, 2023. So that will be indicated up in the upper, and after that the latitude is 51 degrees. So since it doesn't have a exact, so we must use 52 degrees and 50 degrees to interpolate in order to get the 51 degrees. So after that, we must create a table. So it will be look like this. So sunrise, so latitude 52 degrees north. Sunrise is 5:13 a.m. and the sunset is 4:50 p.m. So 51 degrees 28.6 minutes north, and the sunrise is unknown and the sunset is unknown. So the 50 degrees north, the sunrise is 5:16 a.m. and the sunset is 4:47 p.m. RD is 2 degrees. So and the sunrise is 3 minutes and the sunset is 3 minutes. So after that, we must solve for the change of minutes. So in the sunrise, so 2 degrees divided by 3 minutes, so that will give us the result of 40 minutes. Therefore, every 40 minutes there is a change of minutes. So as they say, just like in the sunrise, so our sunset 2 is also 3 minutes. So that will be 2 degrees divided by 3 minutes and will give us the same result of 40 minutes. So therefore, every 40 minutes there is a change of minutes. So after that, we must complete the table. So 52 degrees. So since we already done computing the here the change of minutes, so that will be 50 degrees rather, plus 40 minutes, that will give us the result of 50 degrees 40 minutes, plus 40 minutes, that will give us the result of 51 degrees 20 minutes. So that means that 2 minutes is the change of minutes. So in completing the sunrise, so that will give us the result of, in the sunrise is 5:14 a.m. and the sunset is 18 I mean 5:14 a.m. sunrise and the sunset is 4:49 p.m. So scenario number 2. So in the 10th of April 2023 has a latitude of 45 degrees north and has a longitude of 90 degrees 15.5 minute west and has the time zone of negative 6 hours and the distance of negative 5 hours. So again, just like in the previous, we must find the latitude in the almanac. So first, our given is April of 10th of April 2023. So that blue arrow is the indicators of that, and then we must find the 45 degrees. So since 45 degrees has this exact value here, so we don't need to interpolate. So creating the table, so since the latitude is exactly at 45 degrees on the almanac, then we don't need to interpolate any further and just use the values in the almanac. So in creating the table, so latitude 45 degrees north, the sunrise is 5:23 a.m. and the sunset is 4:40 p.m. So after that, we must find the time difference. So 360 degrees is equals to 24 hours. So therefore, 15 degrees is equals to 1 hour. So 90 degrees, 15.5 minutes, divide 15 degrees. So if you will input that in your calculator, you will get the result of 6.017 hours. So therefore, or let's just say that 6 hours and 1 minute later. So after that, we must find the UTC time on that location. So the sunrise at the latitude of 45 degrees is 5:23 a.m. So the time difference using longitude is 6 hours 1 minute later. So add the two, add. So that will give us the UTC of 11:24. So sunset at latitude of 45 degrees. So for 1840, so and the time difference using longitude 90 degrees 15.5 minutes, so that we give, or 6 is equals to 6 hours 1 minute later. So add, and then we give us the result of 41. So after that, we must convert it to local time. So local in the sunrise, so sunrise at location is equals to our UTC is 11:24. So zone time correction is -5 hours. So that will give us the result of 6:24. And the sunset at location 41. Our UTC is 41, and our zone time correction is -5 hours. That will give us the result of that will give us the local sunset of 1941. So therefore, our conclusion is our local sunrise is 6:24, and our or 6:24 a.m. and our local sunset is 7:41 p.m. And that would be all. Thank you.